We will review a complex example for the advanced level. The aim is to explain step by step how to use interval to divide work and simulate the real construction process, and how to solve some of the main problems we had during this process. Our example is a retaining wall embedded in soil. After the wall was built, a part of soil was excavated in front of the wall and beams were constructed in sequence. Let's browse loading history. So first interval is about boundary conditions. If we click on boundary condition buttons, we can see the boundary conditions for the surfaces. If we go to conditions for surface and then draw color, we can see the surfaces. So the red surfaces, it's constrained or supported in y direction, as we can see one in y, and green surfaces supported in x direction, as we can see one in x position, and the yellow surface supported in x, y, and z. Here we have one important note. These lines shared between one surface constrained on x and the other surface constrained on y. So this line should constrained in both directions, x and y. So all the lines on the edges should be constrained on x and y. Why we can see the yellow, like the number one for x and y position. And if we go down here, also the green line also supported or constrained in x and z, the red supported in y and z. Now second interval, it's about soil. As we explained before, in the beginning all the model should defined as soil. If we click on draw boundaries, we can see the body loads for the model. We defined the body loads for soil. To check it, we can go to conditions, volume, and wait for volume, color. We can see the body load as soil for all the model. Now if we click on show materials, we can see the soil layer material from the top to the bottom. If we go to the materials, we can go to solid soil, and then we can see the materials which we defined. The reason we have different layers is because the E modulus is different for each layer. As we can see here, 2A for soil, it's different of 2B for soil, and so on. As we can see, we have defined separate materials for the wall to be replaced later, but this material, it's exactly the same. For example, 2A for soil, it's the same as 2A for pile. But when we will replace 2A for pile, we need to keep 2A for soil. We don't want to replace it. Just we want to replace 2A for pile or 2B for pile and so on with concrete. If we just activate the concrete layer and we see the material, so we have 2A, 2B, 2C, 2D, 3A, 3B for pile. So all these materials we should have in the same side, like for concrete. So we should have 6 corresponding sections of the concrete. The material here created depends on model code. We had the strength value, and we had like cubic characteristic, and it's enough in GID just to have this parameter, and then you can generate, or we can generate all the other parameters by activate MC general material and then update. So now after we define the soil, now we will or we want to replace the soil material with the concrete material in the part devoted to the wall. So in third interval, we will replace these materials. Firstly, we should mention about, like, you should add additional load case in each interval. It's for interval 1 to have the boundary conditions in each interval. And also we should activate here the box set reference configuration. It means like you should reset the displacement. So in this interval the displacement will go back to the zero. And also to replace the material, we should activate the box show material activity, and in this box we can replace the old material with new material which we created already. If we activate material again, we can see the materials for the wall, 2A4 pile, 2P4 pile, and so on. So this material we should write it in the part old material name, and on the opposite side of each of them the name of the material or the name of the new material must be written. Here also in this interval, if we click on draw all boundary, we can see also we have body load, but just for the part for wall. If we go to body load in condition for volume, we can see we activate or we defined 4 kilonewton because the concrete it's 24 and we defined before 20. So only the difference should be added. So 4 here added, and it's just for this part, the part for concrete. After the wall construction finished and we replaced the soil with concrete, now in fourth interval it will be for construction of P2. So we should excavate the upper part with green volume, and the blue part we should replace the soft material which we have or the soil material and replace it with the hard material by activating the material for the plates. So our plate here with material called 2A soil SP2, so we should write this sentence in the old material and write the name of the new material in the new material. We said we should excavate the upper part, so it means in this interval we should delete the volume, the upper volume. So it means both upper volumes should be deleted. This NGID can done by if we go to the conditions and then go to volume and element activity for volume. Here, like we can see delete. Yeah, we will activate delete and then assign, and then like if we make draw also, we can see like we activated here already. Also here we can see like we activate or we define the loads as body load for this plate, not loads for surface. And it's important note here, if we will activate it as surface, and we have here like one surface, and this surface sharing two volume, the upper which we want to delete and the bottom. And here we can see this node when we will activate load surface, and depending on this node, if we will apply the load for surface, we will have two cases, one load case for the lower volume and one for the upper volume. And when we will delete the upper volume, this load case will stay in the input file. So we will get from the software a message wrong, and the analysis will interrupt it with this message wrong that like the software cannot find the element anymore. To solve this problem, we can divide the load by the thickness of the plate, and we can get the body load and apply it for the plate. After we excavate it from one side, the groundwater effect will start at the opposite side. So in fifth interval, it should be for water pressure from the top till the end of the plate P2. If we go to the conditions and load for surface and we could draw in this interval, we can see we applied the water pressure on this surface in the opposite side till the end of P2 level. Usually we applied a water pressure as a global linear not global constant, because water pressure usually is not constant. At the top is 0, and at the bottom the pressure is the height multiplied by 10. To see the conditions that we entered earlier in this model, we should go to entities, load force for surface, and then this window will appear. We choose one and then transfer. If we go to linear generation, so here we should generate our linear force. Firstly, we should put the coordinate for the first point. We choose the upper point, the middle upper point, so this point. If we go to list and choose this point to see the coordinates, we can see it's like we should put this coordinate here. And then we should put the water pressure in this point, and it was this value. The coordinates for the second point, we can define them by two ways. The first way is to define the coordinates of the point in the same level of the plate, P2, and know the value of the water pressure there and define it. Or in our case, here we had the value of the water pressure at the end of the excavation process. So it's at the end of the plate 5. And also here we can define like this way, like the coordinates for the last point and the water pressure there. And when in each interval we will assign the water pressure for some surface, the software automatically will take the coordinates there, so it will be changed. After defining all required values, we can click generate this button, and then the coefficient will generate according to the equation. If we multiplied this coefficient with the coordinate here and subtract this value, we should get this number or this value. And also if we multiply the coefficient with the coordinate z in the second point and subtract with this value, we should get the y force value. Another important note is if we go to the same interval 5, we can see the interval multiplier 0.5, and this is because we have interface between the concrete and the soil. As we said before, if the surface shares two volumes, the force will be applied twice. So that's the reason the multiplier in this interval was 0.5. As we talked before, the whole model in the beginning is soil, so there's no reinforcement also in the first interval. So we should activate it in the third interval when the concrete defined and the material replaced from soil to concrete. And we can do that if we go to the reinforcement and then go to element geometry tab and unactivate default application, and here we can write the number of the interval which we need. After we delete these parts and we build the P2 plate, now we will excavate again the second part and build the P3 plate. So if we go to the interval 6, here we can see, if we draw the conditions, we can see again like we deleted this volume and we applied the load as body load. We also replaced the material here. Again, if we see the material again for these plates, we can see the material 2A soil SP3, the name of this plate material, and we should replace it with the name or the new name which we made as elastic. Then in 7 intervals we applied the water pressure after we excavate, so water pressure in the opposite side. If we go to load for surface again, we can see we applied the water pressure on this surface. Entities to see the load force, we can see here we used exactly the same values as we used before, and as we said before, the our software will take the coordinates automatically in this surface which we applied. Then the eighth interval, it's about again like excavate pay 4 and then applied water pressure in ninth stage, and then in 10th stage like excavate again pay 5 and the interval after apply water pressure behind as in previous levels. To study the contact between the wall and the surrounding soil, we should define interface element between the wall and the soil around. Let's activate the interface layer to see how we define the interface. So it's between the wall, as we can see, and the soil. Here we can see the material for each part. Here to be clear, like we activate also the concrete layer, and then we can see the interface. To make our node clear, let's delete our interface and make collapse for all the surfaces. So we will have just concrete with soil without interface. So delete the volume and then make collapse from geometry, edit, collapse surface, and then select all the surfaces. Here we don't have to be afraid because we have like compatible model. Here we can see down is like minus 40 surfaces. So we have just now concrete with soil without interface. Now let's think how we will define our interface between concrete and soil. It's clear that we need the interface between the concrete and the soil behind it, and also we need interface between also concrete and the soil like in front of it under the P5 plate, the last blue layer. The most important thing before we create the interface is to think how we will move the part and return it again. For example, if we just moved the concrete part and return it again, it's not correct. We will see why. Let's move our concrete by Z, for example, 1, and select just concrete. So turn off the layers and keep concrete, and be careful about collapse. It should be not activated. Then again, the same number on Z direction but minus, and select again. Why our idea like this is not correct? Now here between the concrete and this part, for example, there's two surfaces, which is not correct. Here we need it to be like one surface. So we should make collapse for all the surfaces in the right upper side. As we said, we don't need an interface between the wall and the right side of it. So here we don't have to have two surfaces. So we should make collapse for all the surfaces in this side between the wall and the green and blue layers till this surface. Here in this surface also we don't need two surfaces. Also we can check here. You can see there's two surfaces because we moved the concrete. So here we should have collapse. Again, by collapse this surface, you can see -2. But when we make collapse for this surface, in this way, this point now it's one point, and this line also is one line. So we can check here one point, and also if we check like here also one line, and this point and this line corresponds to the bottom surface also, which we have interface there. But if we fixed like that, the interface below will not work. So the correct idea is to move the concrete with all these side together and return it together. So in this way, we will not have two surfaces between concrete and the right side, and also we will solve the problem for the interface below. So our idea is, it's like important and very important to think before you make or you will create interface, how you will move and how you will return, because we don't need two surfaces. In some places we don't need it. And also, if we want to make collapse, we should be careful, because if we fix some point or some line corresponds also to the interface, so the interface will not work also. Another important note here about mesh. It should be noted that in any model, the number of elements must be at least 4 per thickness, and we recommend to have 6 or 8 sometimes to catch the perfect bending. And this is important for the concrete volume. So the plates here we defined as elastic, not concrete, so it's okay to have 1 or 2 per thickness. After designing the model and defining all the required parameters, we proceed to the analysis by ATENA Studio. Here we already have some of the analyzed steps, so let's go through each interval to see the effect of it. Firstly, to make it easy, we can view our input file from view input file. Now if we go to the end of the input file, what we have there's a summary in the end for all the intervals what we did, and each interval in which step will finish. So here we can see first step, it's for boundary conditions, it's first interval, and the second interval is one step for the body load for soil. So if we go to the second step, we can to see the model. We can activate draw deformation shape and solid with outline to have a nice view or to see it clear. Third interval is about the concrete and finished in seventh step. So now step number 7, we can go there, and here when this step finished, the material will replaced for concrete, and the reinforcement will activate also here in this interval, and also the displacement will go back to 0 because we activate set reference configuration. Now again we can go to input file to see the interval 4 finished in step number 9. So if we go to step number 9, here we excavate the top part of the soil, and we build or we replace the material for the plate P2. Let's make zoom to see it clear, and let's activate displacement in Y direction to see the effect of the water pressure in the next intervals. So now we have like the displacement on Y. Now the water pressure activate after, so in interval number 5, step 10. So if we go to step 10, we can see we can make also a little bit rotate to see it clear, and always better to activate absolute in deformation shape. Let's put it large number 1500 to see everything clear. Again, interval number 6 finished in step number 12. So if we go to step 12, it will be for excavate another part and building P3. We can see now the water pressure after in the opposite side, it will be in step 13. And then if we go to step 13 to see the effect, now the effect will be more clear. You can see then excavate and build beam P4. So finished in step 15. Let's go to step 15. After that, the water pressure will applied in step 16 behind the wall. Here we can see the effect of the water pressure. Here we still have deformation scale 1500. It's too much. That's the reason it looks the deformation big. And the last one is to excavate and build the last plate P5, as we can see here. ATENA program produced by Chervenka company You can find us via the website and download the program from it, or on YouTube by name Chervenka Consulting, or in Facebook by name ATENA. Finally, we thank you for your attention, and for any inquiries, please don't hesitate to contact us. Have a nice day. Bye bye.